Hello and welcome to our second video for the industry-related manufacturing technology component of the industrial technology timber syllabus for stage 6. We're looking particularly at the preliminary component here, and today's video is looking at properties and characteristics of hardwoods and softwoods. By the end of today, I'm hoping you have a bit of an understanding of the following terms: figure, grain, texture, color, strength, durability, weight, hardness, and weathering, and how they relate to projects. Specifically, what we need to be able to do by the end of it is to identify these properties of hardwoods and softwoods and apply them to our practical projects. So start thinking about how grain, texture, durability, etc. need to be taken into consideration for practical projects. And you also need to be able to discuss these properties and apply them to projects. Now, when we're talking about this, I'm going to go through and explain what they are. You'll need to then think about how you can make those links to your personal projects. So let's start having a look at the first term, figure. When we're talking about figure, we are talking about the pattern or the design produced on the surface of the wood. And this is a visual-based characteristic, and it's really linked to texture, grain, and color. You can see on the screen we've got a fairly regular grain, a little bit straight, but there are some wavy components towards the center left. And so you can think about how the grain, the straight grain or the wavy grain, is impacting on that overall figure. When we're thinking about how figure might apply to a project, because it is really visual based, we're really thinking about how aesthetically it would play a role. So if I'm thinking about times when figure may be particularly important, if you're producing a guitar, for example, if you're producing some sort of decorative surface, those sorts of things, the figure could be really key there. Potentially also if you're working with veneer and you're using a whole heap of contrasting veneers, you might be not only contrasting colors, but also contrasting figures as well to try and get your project to really stand out in that marquetry or parquetry space. Next, we have grain direction. Now, I've got a video here on reading grain direction. I'm not going to play it as part of this video, but it is available on YouTube, and I'll put the link to it in the video notes. I'd encourage you to go off and have a look at it because it really does a great job of explaining how to read grain direction and how that specifically applies to using the thickness planer. One thing that we've got to keep in mind is when we're talking about grain, if you're having a look on the image at the left, you can see we've got arrows, heart side, bark side, grain slope, etc. If you put the timber through in the incorrect way, facing the wrong way as it goes into the thickness planer, the risk you run is that the blades actually pull up the tip of the arrows and therefore rip out some of the heart of your timber. So knowing where your heart side is, knowing where your arrows are, can actually prevent that from happening. And it can be really challenging because sometimes you'll have arrows going both up and down your length of timber. So it's about finding which way is going to be the best. And the way that you do that is by thinking about the grain slope, because we know that these grains are based on the growth rings of the tree. And therefore, and we know that trees are growing upwards towards the sky, thicker at the bottom, thinner at the top. So that would naturally mean that there should be a degree of grain slope. It may be very minute and hard for you to see, but if you can identify it, again, you can work out where the heart side of the tree is and prevent that tear out from happening on the thickness planer. So if we're thinking about grain direction and we're thinking about how that impacts on our projects, it's really related to the machining processes and how to minimize those chances of tear outs, particularly when we're thinking about the thickness planer. The third property or characteristic we want to look at now is texture. And if I said to you that figure was very visual based, then I would say texture is more about the feeling when you rub your hand across the timber. Now, that's how we can determine the texture. We can work out whether it's fine, medium, or coarse. So super smooth, a little bit rough, or very rough. So fine, medium, or coarse being the main ways we describe it. And we can also describe it as being uniform, so consistently fine or consistently medium, or being uneven, where it might be sometimes coarse, sometimes medium, sometimes fine. Now, these differences are most noticeable on hardwoods, and it's fairly closely linked to the size of the pores or the vessels within the timber. So if we know that those vessels are the way that the nutrients are transported, in a hardwood, the vessels are much larger, therefore we can notice it more in a hardwood. And if those vessels are quite large, they'll actually, when they've been seasoned and there's no moisture in them anymore, they're actually little holes. So as you're feeling your hand across the surface of the timber, that rough feeling that you get is actually your feeling of all of those holes within the surface of the timber. If you look at the image on the screen, you look at the coarse one, you can actually see all the little dark colored dots, tiny little holes throughout the timber in a very coarse species. Now, keep in mind what you're looking at there is magnified growth rings. So those dark areas there would be the late wood, the lighter areas where you can actually see those holes are the early wood. So this is super magnified. So it's not something like the holes are sort of the size of a 5-cent piece or anything like that. They're very microscopic in size, but you can actually feel them, particularly if they're really large and there's a lot of them around. If we're then looking at the fine ones, yes, there are holes there. There are always holes. There are always vessels in every species of timber. But because those vessels are much smaller, it feels a lot finer on our hands. Now, if we're thinking about how would we apply texture to our projects, particularly if there was a time when the feeling of the surface was important, that might play a role. But also if we're thinking about the use and the application. So I know, for example, that if I was making a chopping board, I wouldn't want it to absorb a whole heap of meat juices and vegetable juices and things like that while I'm cooking. So I would not want pores. However, for the purpose of keeping my knife sharp, we actually want to use end grain typically, which increases pores. So it's not always a direct link between smoothness and sealing and the texture, because there are other ways that we can go about filling those pores to render them food safe. So when I'm thinking really about texture and how I would apply it to a project, if I was trying to produce something that needed to be really smooth so it didn't, I don't know, cut my skin or feel uncomfortable, maybe if I was turning a timber ring, for example, I might be thinking about a species of timber that has really fine texture so that I don't get irritation on the inside where the ring is sitting on the finger. Okay, so there's some of the considerations. But also if you want a really smooth surface on your dining table or something like that, and you want it to be naturally smooth without having to add a whole heap of finish to it, then again, another time that you would need to consider the texture of the species that you're working with. Color is a fairly obvious property and characteristic of timber, and I've got these images directly from the Wood Solutions website. I find it's really helpful in comparing species on a very even manner. And we sort of think about the timbers can either be sort of white, pale colors, pinky brown colors, brown to red colors, or brown to chocolate colored. So there's sort of, even though there's varied degrees of each of those colors, in four main categories, it's light, medium red, and quite dark. So then all of your tree species fit within these ranges. It's important to know as well that even within a species of tree, you can have variations. Spotted gum, for example, I know from working with this in the past, can be very dark chocolate or can be a light colored brown, depending on which particular part of the tree, whether I got the hardwood or the sapwood, and also where it was grown, the rate of growth, and those sorts of things. There's a whole heap of variations there, but color is really based on visual aesthetics. And when we're thinking about application to projects, we normally would try to either match the colors so that they are identical or as close as possible so that the project looks consistent, or you would specifically be looking for a contrasted color of timber to make different features stand out. This is where sometimes you might see that the drawer face might be a different color to an entertainment cabinet. This is where you might see that the tabletop might be a different color to the rest of the table. So contrasting colors of timber. But when we think contrasting colors, they're usually significantly different. If you're trying to then make them match, that's when you try to match the color profiles up so they're very, very similar. You wouldn't normally put a pink colored timber with a pale or straw colored timber because they're too similar and it then starts to look odd. But you could definitely put a nice light pink colored timber with a dark red timber because they're so different, it acts as a contrast. Next property or characteristic we look at is strength. Now, when we're talking strength, we can think about them in terms of their stress grips. Okay, so how much stress can they withstand? And we talk about these numbers being S1 through to S7. There is an S8 category that is sometimes used as well, but S1 to S7 are the main categories that get used. 1 is the higher strength, 7 is the lower strength. And when we're thinking about this, we need to remember that the weight of the timber is not linked to the strength. There are very, very strong timbers that are not heavy, and there are very heavy timbers that are not necessarily strong. So it's not a direct comparison there. Strength is actually related to the type of cells, the structure of them, the size of them, and those sorts of things. So even within species, there will be variations. But generally speaking, we're categorizing some main species. Pine sitting towards the low end, not very low, but quite low. Jarrah sitting comfortably towards the middle. Spotted gum sitting towards the top, not the highest, not the most strong, but sitting towards the top there. So there's a fairly even comparison there. Again, this information is coming from the Wood Solutions website. Great resource. Durability, another one of those characteristics and properties that we are thinking about. Durability is where we start to think about the resistance of this species to insect and fungal attack. It's not a link to hardness or strength or anything like that. It's resistance to insects and fungus. So we're normally thinking that the center of the tree, the heartwood, that's filled up with the gums, filled up with the resins and all of the waste materials from the tree, because it's full, is usually more durable because there's no opportunities for fungus to grow and it's harder for the insects to eat through. However, that really light sapwood on the outside of the tree with really thin cell walls, they're not clogged up, lots of big open vessels, much more open to attack, therefore less durable. In that same sense, we can then start to compare them on a low to high scale. And you can see that there's some year ranges sort of attached there. Spotted gum, very durable, very much resistant to insect and fungal attack. We're thinking about application as well. Spotted gum is one of the few species that's actually been fire rated for use in bushfire areas. So it's a really, really great species in terms of durability. Jarrah, another good species, not the best, but a good species. Pine, very low durability. Okay, it's a softwood. It's grown very rapidly. It's got really big or really thin cell walls. It's got that nice light color. Therefore, very susceptible to attack from fungus and insects. Keep in mind that you can work with pine on a long-term basis by treating it so that it's got increased resistance to fungus and insect attack. And that's where treated pine, which you may have heard, comes from. Weight. Now, weight is the term that we have sitting in the syllabus, and weight can be very confusing because people often think, how many kilograms is it, and those sorts of things. Really, the term that I prefer to refer to is density, because it's how much mass per space available. Okay, so it's a calculation of how many kilograms are there in every cubic meter of this species of timber. So what I mean by that, if I got a cubic meter of pine, so if I got a pine and filled a meter by a meter by a meter, completely full, no air, and I weighed it, it would come back at around about half a ton, 550 kilograms. If I did that same space, a meter by a meter by a meter, that cubic meter space, and filled it with spotted gum, again, no air, just the timber, we'd be looking almost double that, at 990 kilograms. Okay, so density is related to how much mass, so how many kilograms are there within a certain space area. We always do it based on cubic meters, so then we're consistent and we can compare species. So in that sense, we've got pine sitting towards the low, jarrah sitting reasonably high, that high medium, that low high, whatever you'd like to call it. I call it reasonably high. And we've got spotted gum sitting up there right towards the top. Now, this is a scale, so there's not one species that's always going to be the most dense and one that's always the lowest dense. Within the species, there's going to be variations, so something to consider there. When these calculations are done, though, to try and make it consistent, this is done when the timber has been dried to 12% moisture content. So if we're talking about, you may have heard us talk about EMC, equilibrium moisture content. In Sydney, that's around about the 15% mark. They specifically dry this down to 12% to keep it nice and consistent in their measurements. And that's how they do their calculation. Obviously, if they did it when the timber was green, it would be significantly heavier and wouldn't be a great result, because depending on how green it is, how much moisture is in it, it would change the weight. So they dry it down to 12%, so it's consistent, and then make their measurements. We're thinking about density, thinking about projects. This is where, if you're considering a project where weight is an issue, so maybe the transportation of it, safety issues around how you're going to carry it, how you're going to move it, if that's an issue for you, you might need to be looking at a timber that has a lower density, so you don't have as much weight sitting in your project. Particularly if we were talking, maybe we're going to mass produce or work in a factory and we're going to have shipping costs. Shipping costs are very much related to the weight of the item being shipped. So the heavier your project, the more it's going to cost to ship. And so that's another thing to keep in mind when designing projects. Next, we have hardness. Now, hardness is measured on a scale known as the Jenker rating, or the Jenker hardness test. This is a test that's been designed, they've been using it for years. They effectively get a metal ball bearing, a steel ball bearing, looks like a marble, you can see it on the screen there, and they push it into the timber until it's been embedded to half the depth of the timber. So if the timber is 20 millimeters thick, they push it in 10 millimeters into the depth, and they measure how much force is required to push it in. And that then gives us an idea of how hard these species are. Now, I know that test sounds really bizarre. Why would you push marble in? No one actually does that. Well, think about application to project. If you hit a nail into a timber that's quite soft, like let's say pine, for example, it's going to push straight through. Whereas I compare that to an experience I had a few years ago where I had a student trying to put a screw into some jarrah for a hinge on a door. And they'd pre-drilled the hole, probably 0.2 of a millimeter too small in terms of the diameter they pre-drilled, because they were using the drill bits available, not necessarily the absolute correct one. And then when they're trying to put their screw in, they're twisting it by hand using a screwdriver, and the head of the screw actually snapped off in a pre-drilled hole, because the hardness of jarrah is so high that it wasn't able to split or compress to fit the extra space needed by this screw. So hardness is actually something you want to consider. It also will help you work out how durable your project is going to be, not against funguses, not against insects, but how durable it will be against physical damage. So if we're thinking about projects that might be used as a workbench, where they're constantly getting hit by tools and things like that, you might be looking for a timber that has a high hardness. Maybe you're looking at floorboards in a house, high hardness, so that when people are putting their furniture down, they drop things on the floor all the time, that you're not constantly getting dents in your timber. If you use a really soft species, you're going to have lots of dents occurring. The last one that we're looking at here in terms of properties and characteristics of hardwoods is weathering. And weathering is the process of your timber going silver or grey because of oxidation. So basically, your timber is exposed to the air, exposed to the sunlight. A chemical reaction happens where the colour of the wood eventually is faded out. Okay, it's released by that UV radiation and exposure. And you can see up on the screen there, might start with this beautiful yellow coloured pine. Think of a brand new timber fence that's just been installed in your neighborhood, and then you go back a few years later, and it might be completely grey. So grey or silvery colour. Okay? That's the result of weathering. You can work around weathering by using preservation techniques, so finishes, to try and seal the cells of the wood to stop that chemical reaction happening where those colours are then fading and being drawn out. Okay, so that's the last of the properties and characteristics of the wood. Where would I consider this one being included in the thought process around a project? If I was coming up with a project that maybe was going to be used as outdoor furniture, and I was thinking about how much finish should I apply, how often should I apply it, what happens if I don't apply it, weathering is something that I would need to be considering there. Okay, so that's the end of those ones. Our next video, we start looking at industry-related terms for grade and sizes of timber and manufactured boards, and then onto timber defects. So hope that one's been helpful for you, and good luck with your study.